In this video, we're going to be looking at kinetic energy and how that kinetic energy can be used to describe how gases, liquids, and solids move and how they act. So first of all, we need to know what kinetic energy is. Kinetic energy is the energy that you have when you're moving. So whenever you hear the word kinetic, you want to think of motion. You have kinetic energy when you're walking, running, even if you're just sitting in place but moving your hands. Now, the faster the object moves, the more kinetic energy it has. So if we look at gas particles, if the arrows represent how quickly they're moving, notice these arrows are very short. That's because they're in a cool environment, and so they're not going to be moving quite as fast. But when you heat the gas up, now they're moving much quicker, so the arrows are much longer to represent that faster speed. Kinetic theory of matter just says that all particles are in constant motion. So even solids, even though they don't flow and they keep their shape, they're still moving. Gases are moving as well, and so are liquids. Now, we can use the kinetic theory to describe how gases behave. First of all, gases never stop moving. The particles are constantly at motion, and they move in a straight line, so they're not zigzagging any way they want. They move in a straight line until they collide with either the wall of the container or with another particle that might make them change their direction. Now, if you've ever played pool, you know how this works. When two things hit each other, one is going to slow down, it's going to lose kinetic energy, while the other one is going to gain the kinetic energy. So when you hit a pool ball, that cue ball here stops, but yet that causes this ball that was on the end to move forward. So this one has lost kinetic energy, but this one is now moving, so it's gained kinetic energy. So as far as the kinetic theory of gases, again, it just says that they're in constant motion, and because of that motion, gas particles can fill up their container. So they're going to keep moving until they hit the lid. If there's no lid, then they're going to move out into the room or wherever they're at. And they're always in constant motion. And the motion of one particle doesn't affect another. So this particle up here, the fact that it's moving in a certain direction doesn't change the fact that this one over here is moving in a different direction. The only time that two particles are going to be affected by each other is if they collide or hit. The force of attraction between particles in a gas is very small. So because these gas particles are constantly moving, like that last picture showed, they are attracted to each other because there's still gravity, but it's so weak that causes them or allows them to be able to move away from each other. They're not stuck close together like liquids and solids would be. Now, let's look at liquids. Liquid particles are still moving because the kinetic theory of matter says that all particles are in constant motion, but they do have less kinetic energy than a gas does. So this allows them to take the shape of their container because they can move, have a little bit of space between the particles, not nearly as much as a gas, but they do have some space, and so that allows them to flow and take the shape of their container. But because they're still close together, they have a much higher attractive force. This keeps the particles close enough together that the volume doesn't really change. And then lastly, with solids have the most restrictions. They have a definite volume and a definite shape. And solid particles vibrate in a fixed spot. So kind of like you sitting in your stool, your hands are moving, your feet are moving, maybe your body's moving, whatever. But you're still in a fixed location. You're still sitting on that stool. That's kind of how that's how I think of them anyway. So they're still moving, but they're more like vibrating in place instead of actually being able to pull away from each other like liquids and gases can. And that's about kinetic energy, and that's where we're going to stop for today. Please let me know if you have any questions.